You've probably seen Pascal's triangle before, but you've probably never seen how it relates to combinations. So you can see that each number comes from a sum of the numbers above it. Okay, 3 comes from the 1 plus 2, and this 10 right here comes from 6 plus 4. So we can create a new row by putting a 1 here, and then you add, and you get 6. And add these two, you get 15, and add these two, you get 20. And you've probably seen this relationship before. We can always make a new row by adding the two numbers above. So there's a 7 and a 21 and a 35 and another 35 and another 21 and a 7 and a 1. But what you probably didn't know was how it relates to combinations. So check it out. Take any row and say this row, and I'm going to call this the 4th row because there's a 4 in it, basically. But if n equals 4, if you start counting at 0, 0, 1, 2, 3, 4, you end up at that number. Okay? It doesn't work unless you start at 0, so make sure you start at 0. So for the 7th row, if you start at 0, 1, 2, 3, 4, 5, 6, 7, notice you end at 7. Okay? So how this works is if you're doing a problem like 4 choose 2, you go to the 4th row and 0, 1, 2, 4 choose 2 equals 6. And so for 5 choose 3, you go to the 5th row and count to 3. 0, 1, 2, 3. 5 choose 3 is 10. And so 6 choose 3, start at 0. 0, 1, 2, 3 is 20. And 7 choose 5, go to the 7th row. 0, 1, 2, 3, 4, 5 is 21. Pretty neat how that works. Number 5. If each member of a 9-person jury acts independently of each other and makes the correct determination of guilt or innocence with probability 0.65, find the probability that the majority of jurors will reach a correct verdict. So you can see a couple of things. You can see that they're talking about n equals 9 and probability is 0.65. But the X number is a little bit harder to see. But they use this language of the majority of jurors. And so we know majority means more than half. And so if you think about it, you had a 9-person jury, more than half means at least 5. Or in other words, 5 or 6 or 7 or 8 or 9. That would be a majority. So 5 or 6 or 7 or 8 or 9 jurors are going to have to vote the way we want them to. Okay? So this becomes a sum problem. We have to add up a bunch of things. This plus this plus this plus this plus this. Okay, so we've got several things. I'm going to try to write small, but it's going to be hard to fit all this in there. So what do we have? 9. Choose 5. So we've got 5 successes, so 0.65 to the 5th power. And that means the failure rate is 0.35, and there are 4 of them because that produces 9. Plus 9 choose 6, 0.65 to the 6th, 0.35 to the 3rd, plus 9 choose 7, 7 and 2, plus 9 choose 8. We've got 8 successes and 1 failure, plus 9 choose 9. We've got 9 successes and 0 failures. All right, so we have to find those. We have to add all of those up. So, again, something that might help is if 0 power is 1 and 9 choose 9 is 1. couple of things like that might save a little bit of time. We're going to plug all of those things in. And I know you already know how to plug them in. So when you plug in this one, 9 choose 5 times 0.65 to the fifth times 0.35 to the fourth, that's going to be 0.2194 plus this one gives me 0.2716 plus this one, 0.2162 plus this one, 0.1004 plus the last one, 0.0207. Okay, so we have to add all those up. You add all those up and you get about 0.8283. Now let's see how to do a problem like this using technology. Here we have a TI, and what we're going to need is the distribution menu. So hit second and vars to get your distribution, and arrow down until you see binomial probability distribution function. We want PDF. So some of your calculators are going to look different, but we want these three values in here. You've got 9 trials in this one, a 9-person jury, and the probability was 0.65, and we're going to have an X value for this of 5. So some of your calculators are going to just look like this, but make sure you enter in the same 3 arguments. You've got your N number is 9, your P number is 0.65, and your X number is 5. You get 0.2193, which is what we would expect. That's what we got right here. 0.2194 was what we did when we typed it in the old way. And here was the old way. If you want to do that, you can, I suppose. 9 choose 5 times 0.65 to the fifth times 0.35 to the fourth. Same thing. All right. So use the function or use the old way. Either way, it doesn't really matter. But we want a shortcut for typing in all of these. So that's where that CDF comes in, if you noticed. So go back to the distribution menu and pick the one that says binomial CDF. C stands for cumulative. And what cumulative is going to do is it's going to add up all of the things from 0. So in this case, from 0 to 5. Okay, now that's not the answer because that's not what I did here. I didn't add up the numbers from 0 to 5. I went from 5 to 9. And so really what we would want to do is take out from 0 to 4. So I'm going to try this again. Let's see. Binomial CDF. And let's change this to 4. Okay, 0.1717. Now again, you notice that's not the right answer, but that's because it's not adding 5, 6, 7, 8, 9. It's adding 0, 1, 2, 3, 4. So what we would have to do is take 1 minus that answer because we want everything else. All right, remember the rule, probability of E equals 1 minus probability of not E. That's kind of the concept that I'm using there. So we can use this calculator to, kind of condense all of this work. Now, let me show you another option. You can go to a website and find the link for binomial distribution. And you have the same 3 arguments here. So probability of success is 0.65, number of trials is 9, and the number of successes is 5. Okay. So when it calculates, it gives you 5 different answers. And so you have to pay attention because it's kind of hard to read at first. But notice this says x equals x. Well, little x equals 5. So this says x equals 5. The binomial probability when x equals 5 is 0.2194, and that's exactly what we got right there, right? When x equals 5, it was 0.2194, just like over here. That was a PDF, basically. But then you've got these other options. X is less than 5, x is less than or equal 5, x is greater than 5, x is greater than or equal 5. And if you think about our problem, 5, 6, 7, 8, or 9 jurors, we wanted greater than or equal to 5. And so this calculates directly. It says greater than or equal 5 right here is this number, 0.8282 or A2A3. And that's what we got, right? So I kind of like this website a little bit better than the TI. We had a little bit more work to do over here with the TI because we had to use the CDF and we had to know that it only goes from 0 to whatever this number is right here. So we had to say from 0 to 4 was this number, and then 1 minus this number is 0.8283. So there's a little bit more steps with your TI, but it'll get you there. I think this is a little bit more direct if you're looking for a shortcut.